Hello everyone, welcome to Excel Engineering Education. In this video, we'll discuss about stiffness matrix method and we will solve a problem related to the frame. This is a non-sway frame ABCD having BD, a point load of 120 kN from B. As per our steps, let us first identify the unknown displacement. When we see this frame, support C and support D are fixed. That's why there will not be any displacement here in these two supports. So ultimately there will be two unknown displacement, that is one at A and one at B. So we'll give the rotations along this unit direction 1 and a coordinate direction 2. Our second step is to find the fixed end moments. Here for AB and BC there is no any loading, that's why fixed end moment will be at only BD and DB. Let us calculate a fixed end moments, that is MFDB. Here we already know that it is eccentric loading, that's why it will be WAB square divided by L square and WA square B divided by L square. So ultimately MFDB is equal to minus 120 into 3.2 into 1.6 square divided by 4.8 square is equal to minus 42.66 kilonewton meter, and an MFBD is equal to 120 into 3.2 square into 1.6 divided by 4.8 square, that is nothing but 85.33 kilonewton meter. Now next step is to identify the P and PL matrix. Here when we see along the coordinate direction 1 and along the coordinate direction 2 there is no any loading, that's why our P matrix will be 0 0. Now next we want to find out the PL matrix. When we see regarding with the PL matrix for coordinate direction 1, that is AB, there is no any moment. For MFAB there is no any fixed end moments, that's why first coordinate direction the value will be 0, and the second coordinate direction, that is B, second direction, that is BA, MFBA plus MFBC plus MFCD, but MFBA and BC is 0, that's why MFBD itself will be there, that is nothing but 85.33. so this is all about P and PL matrix. Now next we want to give a unit displacement in the coordinate direction 1. Whenever we want to give in coordinate direction 1, the effect of that will be up to 2 only. Therefore, using our formula K11 is equal to 4EI by L. L is near 4 meter, that's why K11 is equal to EI. That is K11 is equal to EI. We already calculated this part. Next K21, therefore K21 is equal to 21, that's why it will be twice of EI divided by 4. So ultimately K21 is equal to 0.5 EI. When we calculate these things, we calculate K21 means we already calculated K12, no need to calculate again. Next, now we will give the unit displacement along the coordinate direction 2. When we give coordinate direction 2, there are 3 members are meeting. This is K1 ABA, BC and CD also. And when we see regarding with its EI is going to change. For AB it is I, for BC it is 2I, and for BD it is 3I. Therefore first calculate K22. K22 is nothing but 4EI by L, 4EI by L plus 4EI by L. So ultimately it will be 4EI by L plus L is for AB, it is 4. That's why it is 4 plus 4E into twice I divided by L. This is for BC, it is 2I. That is L is 8 meter plus 4EI by L. Here L is 4.8 meter. Therefore 4E into thrice I divided by 4.8. So ultimately K22 will be 4.5 EI. So this is all about calculation of stiffness matrix for the frame. Now next we will calculate a K12 also. K12, this is only for effect is only for AB. Therefore K12 is equal to twice of EI divided by L is 4. So ultimately our K12 is equal to 0.5 EI. So we calculated stiffness matrix, which is a 2 by 2 matrix having the values K11, K12, K21 and K22. Our next step is stiffness equation. We already know that stiffness equation is K into delta is equal to P minus PL. We already calculated K matrix. Let us take a common EI. Therefore EI into first is 1 into 0.5, then 0.5 and the next is 4.5. So which completes our K matrix. Now delta, there are two unknowns, that is delta 1 and delta 2, out of which delta 1 is at A and delta 2 is at B, that is theta A and theta B. Now next is P minus PL matrix, that is 0 minus 0, then 0 minus 85.33. Now we have to solve this matrix, this equation. For that, let us find out delta 1, delta 2 is equal to 1 upon EI into inverse of 1, 0.5, then 0.5 and 4.5 inverse into 0 minus 85.33. So next is inverse of it, that is 1 upon EI into 1 upon 4.5 minus, that is 1 into 4.5 minus 0.5 into 0.5, so 0.5 square into, we have to exchange the diagonal values, that is 4.5, 0.5, then 0.5 and this is 1, but here this minus will be there and 0 minus 85.33. So ultimately when we solve it, we will get values as 1 upon EI into 10.039 and minus 20.078. So this is all about delta 1 and delta 2. Here delta 1 is equal to theta A, that is nothing but 10.039 divided by EI, and delta 2 is equal to theta B is nothing but minus 20.078 upon EI. So we calculated these unknowns using a stiffness equation, that is theta A and theta B, that is a rotation along those coordinate direction. Now next we want to find out a final moments. For that final moment we will use a slope deflection equation. Now here I am going to use the directly value. For slope deflection equation, we already know that for our calculation, for we already know MAB is equal to MFAB plus twice EI by L into twice theta A plus theta B minus delta is equal to 0. Here delta value is 0, that's why I will write down directly, that is MAB is equal to, there is no any fixed end moments for AB, therefore it is 0 plus 2 EI by 4 into twice theta A, that is 10.039 divided by EI minus 20.078 divided by EI. So ultimately when we solve it, we will get a moment at A is equal to 0. Therefore MAB is equal to 0. This is the final moment at AB. Now BA, for this M, BA is equal to 0 into twice EI by L is 4 into 2 into 20.078, which is minus value, divided by EI, plus 10.039 divided by EI, it will be the same value, and delta is 0. That's why MBA is equal to minus 15.059 kilonewton meter. So this is the value for MBA. Now next we want to find out for MBC. Therefore MBC is equal to, here also there is no any external force, that why MFBC is 0. 0 plus twice E into twice I divided by L is 8 into twice into minus 20.078 divided by EI. There is no any delta, that's why ultimately that value, that is moment at C, is 0. We don't have any value for C, plus 0, and delta is also 0. Therefore MBC is equal to minus 20.078 kilonewton meter. So this is the value for MBC. For BC we don't have value moment at C, that is theta C, we don't have, that's why it is 0. This is only twice of theta B. Now next is MCB. MCB also fixed end moment are 0. It will EI twice E, I is 2I divided by L is 8. Now next to this we want to calculate the value for that is nothing but C, twice theta C is 0, plus it will be only 20.078 divided by EI plus 0. Therefore MCB is equal to minus 10.039 kilonewton meter. After this calculation we will get this answer. Next is MBD. Here also for MBD, yes, there is a fixed moment, that is 85.33 plus twice E into thrice I, L is 4.8 meter, into twice of minus 20.078, that is theta B, divided by EI, plus theta D, no any value for theta D, and then no any value for delta. So ultimately MBD is equal to 35.13 kilonewton meter. So this is all about the fixed in the final moment at MDB. Now last is MBD. After that MDB. For MDB, fixed in moments are minus 42.667 plus 2E into thrice I divided by 4.8 into 2, there is no any, twice into 2 into 0, this is for D value, plus minus 20.078 divided by EI, which is value of theta B, plus delta is 0. So ultimately MDB is equal to minus 67.76 kilonewton meter. So which completes the problem, that is calculation of final moments. After that the problem will going to be complete. So this is all about non-sway frame using stiffness matrix method. Let us solve a second problem, which is a sway frame. Here it is unsymmetrical frame. Also due to this 50 kilonewton loading, it will going to be deflected towards right. So ultimately this is a sway frame. This frame contains A, B, C, D, where A and D end are fixed support, B and C, these are the intermediate joints, and BC contains 30 kilonewton per meter loading UDL. And at a B joint there is a horizontal force of 50 kilonewton. Now next step is Step 1, that we want to identify the unknown displacement. So ultimately this frame, due to this 50 kilonewton loading, it will going to be deflect towards the right side, and there will be definitely rotation at B, but there will not be any unknown displacement along A and D because these are fixed end. That's why for this frame there will be three unknowns, that is along direction 1, along direction 2 and along direction 3, where 1 and 2 are at B and 3 is at C. So this, due to these three unknowns, definitely this frame will be having 3 by 3 matrix. Now next step is to find the fixed end moment. Here we can find out a fixed end moment only for BC and CB because there will not be any fixed end moment for AB and CD. Therefore MFBC is equal to minus 30 into 4 square divided by 12, WL square by 12, that is nothing but minus 40 kilonewton meter, and MCB is also plus 40 kilonewton meter. Now next step is to identify P matrix. Here along this coordinate direction 1 there is one force of 50 kilonewton, but along this coordinate direction 2 and 3 there is no any force. Therefore P matrix we can write as 50, 0 and 0. Coordinate direction 1 there is a 50 kilonewton load which is a horizontal. So this is all about P matrix. P matrix is nothing but a matrix in which external or additional forces along those coordinate directions we have to write down here. Now next is PL matrix. For this PL matrix, along coordinate direction 1 there is no any fixed end moments, so that will be 0. Along coordinate direction 2, yes, there is a fixed end moment, that is MBA and MBC, but BA is not there, therefore BC itself there, that is nothing but minus 40. For coordinate direction 3, it will be addition of MCB plus MCD, but MCD is not there, that's why it will be only MCB. So this is all about P matrix. Now next step is to identify the K matrix or to find out a K matrix. For that, first give the unit displacement in the coordinate direction 1. Whenever we want to give the unit displacement in coordinate direction 1, this will going to be deflect like this. So when it going to be deflect, it will have the value of 12 EI divided by L cube. So ultimately this is will be 2 cube, and here will be 12 EI divided by L cube, that is nothing but 4 cube. This is the horizontal displacement value. Ultimately this will going to be reverse also for the stability, so it will be again 12 EI divided by 2 cube and 12 EI divided by 4 cube. So these values are nothing but 12 EI upon L cube. Now next is about, due to this deflection there will be some moments or moment will going to be developed. Those are nothing but 6 EI divided by L square. So this will be 6 EI divided by L. L is nothing but 4, so 4 square, and here will also same, that is 6 EI divided by 4 square to balance that. So ultimately here will be the same, that is nothing but 6 EI divided by L square. L is 2 square and 6 EI divided by 2 square. So now next find out K11. K11 is equal to, here K11, that is along coordinate direction 1 only, that is nothing but 12 EI divided by 4 cube plus 12 EI divided by 2 cube. Ultimately this value is 1.68 EI. Next is K21. Due to 1 there will be 2 effect, along 2 there will be effect, that is nothing but K12 is equal to minus 6 EI, this is anti-clockwise, divided by 4 square, that is nothing but minus 0.37 EI. Next is K31, that is nothing but K13 is equal to minus 6 EI divided by 2 square. ultimately this is minus 1.5 EI. So K11 is 1.6 EI, K21 is minus 0.37 EI, and K31, that is K13, is equal to minus 1.5 EI. Now next we will give the displacement in the coordinate direction 2. When we give a coordinate direction 2, now it will be as usual we solved, that is K22 is equal to, there are two members BA and BC, therefore 4EI divided by L is 4 plus 4EI, L is 4. So this value is nothing but twice EI. Next is K32 or K23 is equal to, it will be now twice EI. So 2EI divided by L is 4. So this value comes to 0.5 EI. So these are the values. This is K11, K12, K21, K31, K13, K22 and K32 and 23. Now next, let us give the unit displacement in coordinate direction 3. When you give for 3, it will be K33, that is nothing but again 4EI by L. For this, L is 4 plus 4EI by, for second, that is CD, it will be 2. So ultimately K33 is equal to thrice of EI. So this completes our complete stiffness matrix method. Now we will use our stiffness equation to calculate the unknowns. So our next step is step 5, stiffness equation. Here K matrix is of a 3 by 3 matrix. So ultimately this will be EI into K11 is 1.687, then it will be minus 0.375, K12, K13 is minus 1.5, K21 is 0.375, then K22 is 2, K23 is 0.5, K31 is 1.5, K32 is 0.5, then K33 is 3. Here delta are 3, that is along coordinate direction 1, 2 and 3, therefore it will be delta 1, delta 2 and delta 3, and P minus PL matrix will be 50, 40 and minus 40. So we already calculated P and PL matrix separately. If we minus it P from PL, PL from P, we will get a P minus PL matrix. Now we want to find out delta 1, delta 2 and delta 3. So whenever we want to find out, ultimately we have to take the inverse of this. So 1 upon EI, then inverse of 1.687 minus 0.375 minus 1.5 minus 0.375 to 0.5, then minus 1.5, 0.5, then 3 inverse of it into 50, 40 and minus 40. So using these values we can find out the value. Now we need to find out the inverse of 3 by 3 matrix, and after that we will get an answer. When we solve this 3 by 3 matrix for this inverse, we will get equation as delta 1, delta 2 and delta 3 is equal to 1 upon 5.3437 EI into 5.75, then 0.375, then 2.812 matrix, that is nothing but again 0.375, 2.812, then next is minus 0.28, then next 2.812, then it will be I think minus 0.28 and 3.23 into 50, 40 and minus 40. So using this we can get the value, that is 1 upon EI into 35.556 then 26.667 and 0. So after this calculation we will get values as delta 1 is equal to 35.556, delta 2 upon EI, delta 2 is equal to 26.667 upon EI, and delta 3 is equal to 0. So this is all about our unknowns using stiffness matrix method, that is delta 1, delta 2 and delta 3. Now this value we can substitute in the slope deflection equation and we will get a final value. Here definitely there is a value which is nothing but a deflection also, that is delta. Now let us substitute these values into the stiffness matrix method and find out the final moments. Okay, for the calculation of final moment we already know that delta 1 is equal to 35.55 EI, which is a horizontal displacement, that is delta. Then delta 2 is equal to 26.667 upon EI, which is theta B, and our delta 3 is 0, that is theta C is 0. So now next we will find out the values for MAB. Here MAB, there is no any fixed end moments for AB and BA, again CD and TC. So now let us solve for MAB. MAB is equal to twice of EI divided by L is 4 into 0 plus 26.667 upon EI minus 3 into 35.55 upon EI. So ultimately the MAB will be 0. Next is MBA is equal to twice of EI divided by 4 into 1 upon EI into 0, because B is theta, B is twice, theta A is 0, therefore theta A I have written first, plus twice into 26.66 minus 3 into 35.55 divided by 4. So ultimately MBA is equal to 13.33 kilonewton meter. So this is all about MBA. We already know that MAB is 0. Now next MBC. Therefore MBC is equal to twice of EI divided by 4 into twice into 26.667 plus 0 divided by EI. I am taking it divided by EI minus 40. Minus 40 is MFBC. Therefore minus 13.33 kilonewton meter. Therefore MBC is equal to minus 13.33 kilonewton meter. After these calculations we need to calculate for MCB. Therefore MCB is equal to twice of EI divided by L is 4 into 26.667 divided by EI plus 40 is equal to 53.33 kilonewton meter. Therefore MCB is equal to 53.33 kilonewton meter. Now next we need to find out for MB. We calculate MAB, MBC, MCB. Now it is MCD. For the MCD it is equal to twice of EI divided by 2 into 0 minus 3 into 35.55 divided by twice of EI is equal to minus 55.33 kilonewton meter. Therefore MCD is equal to minus 55.33 33 kilonewton meter, and the last value will be MDC. Therefore MDC is equal to twice of EI divided by 2 into 0 minus 3 into delta, that is 35.55, divided by twice of EI is equal to again minus 53.33 kilonewton. This is also this is 53.33 kilonewton. Therefore MDC is equal to minus 53.33 kilonewton meter. So this is all about the final end moments for a sway frame. So using these methods, using stiffness matrix method, we can solve a non-sway and sway frame also. Depending upon the unknowns, the matrix will be decided. If there are two unknowns, there will be the two matrix, and if there are three unknowns, there will be 3 by 3 matrix. So which completes our problem related to the frames solving stiffness matrix using stiffness matrix method. Thank you for watching. Kindly like, share, subscribe. Excel Engineering Education.